Alright, in this video we're going to talk about how we identify numbers on a number line. The first thing you see here is a picture of a typical real number line. It shows all the integers from -5 to 5. Now of course we could extend the number line or look at a different piece of the number line, like maybe we could look at the number line from 5 to 10 or from 15 to 25, depending on the numbers that we're looking at. And of course, on this number line, we can also graph any real number. And so we can plot numbers that fall in between any two of the integers where we have hash marks on the number line. And we can really just basically use this number line to identify the location of any real number. And this can be a useful tool for us later on when we're comparing the sizes of multiple real numbers. But the typical number line that you see starts out with, 0 in the middle, and then goes off to the right with positive numbers increasing in magnitude as we move away from 0. And as we move to the left from 0, we have negative numbers. And the negative numbers are also increasing in magnitude. For those of you who aren't familiar with the term magnitude, magnitude basically just means the size of a number regardless of its sign. So for instance, -7 has a larger magnitude than -4 because 7 is bigger than 4. And so -7 is further to the left on the number line than -4 is. All right, so let's get down to the brass tacks and identify a few numbers on the number line and do a handful of problems here. All right, we're now going to plot the following numbers on the given number line, and we're going to start with the square root of 11 in part A. Now, where is the square root of 11? Where does it fall on the real number line? And there's a couple of different ways that we can think about this. First of all, we can think about square roots of perfect squares that many of us should know. For instance, I know that the square root of 9 is 3. And I know that the square root of 16 is 4. And so since 11 is in between 9 and 16, I know that the square root of 11 should be between the square root of 9 and the square root of 16. So it should be between 3 and 4. Now, where exactly does it fall in between 3 and 4? Well, we're going to have to estimate. And I could use some basic estimation techniques, but something that we're going to do is we are going to definitely use our calculator to go ahead and find the decimal approximation for the square root of 11 to give us a better idea of where that number should be plotted. And so I find a decimal approximation. It's 3.31, etc. So that's going to be between 3 and 4. It's less than 3.5, so it's going to be a little closer to 3 than it is to 4. And so we're just going to roughly plot the square root of 11 right about here on our number line. Okay? And again, as far as the decimal decimal precision here, no one's going to be able to tell the difference between 3.3 and 3.316624779 on the number line. So don't sweat those details too much. If we approximate it at about 3.3, that should get us close enough to plot the point on the number line. All right, next, -12/5. And again, like we did with the square roots, I could think about numbers that I turn into integers when I write them as fractions. For instance, -10/5. We know that 10/5 should reduce to 2. So -10/5 would be -2. This gives us a general idea of where -12/5 should be. But again, let's just turn to our calculator. I'm going to go ahead and find the value of -12/5. That's -2.4. Now, -2.4, forget about the sign for a second. 2.4 falls in between 2 and 3, which means that -2.4 should fall in between -2 and -3. A little bit closer to -2 than it is to negative 3. And so that's where we're going to plot negative 12 over 5. And the last one here, 1.75. We don't need to worry about using the calculator to give us a decimal approximation since this is already in decimal form. 1.75 falls in between 1 and 2. And it's actually halfway from 1.5 to 2. So I'm thinking about halfway in between 1 and 2, and then halfway in between that and 2. And right about there is where I'm going to plot 1.75. All right. And now on to the last page. Which of the points on the number line represent negative square root of 7? So we're going to plot negative square root of 7 on here. Let's see. Again, I'm going to turn to my calculator to give me a decimal approximation. Get negative 2.645. So it's in between negative 2 and negative 3. A little bit closer to negative 3 than it is to negative 2. And so that is the point on the number line that's going to represent the negative square root of 7. All right, that concludes this lesson. Go ahead and work on your problems on identifying numbers on a number line.